Dear students, in this video I am going to start sequencing problem. Sequencing and scheduling problem talks about a set of jobs, tasks that have to be performed on given machines by using available resources facilities. So here certain jobs are assigned to perform on certain number of machines. Fine. So jobs are performed on machines so that total cost and elapsed time should be minimum. So here our target is to find out the minimum elapsed time. Here scheduling refers to the time of arrival, departure of units requiring services. Fine. And these type of problems is related to develop a timetable. Similarly, sequencing refers to select an appropriate order to which the customers get the service. And here the problems are referred to order. Order the that means develop the sequence to minimize the time. A general sequencing problem is described herein. So let there be n number of jobs which have to be processed one at a time at each of m number of machines, denoted by capital A, capital B, capital C. Fine. So the order of machines for each job in which it should go to the machines is given. Fine. So here the order of the machines for which each job is already assigned. The order of machines is already given to you. The time requiring by the jobs on each of the machine is also given to you. Fine. Then the problem is to find out the sequence. That means when n jobs are performed on, for example, on machine A, then there are total possible way is factorial n, because their order may be is not assigned, is not given. Order of machines are given, but order of jobs is not given. For example, nth job may be done first, then second job, then for example say n minus 1th job done third, and so on. That means we are having combinations, total possible combinations to perform all these jobs on machine A is factorial n. Similarly, they may be performed on B in factorial n times, and so on. So total possible sequences is factorial n, because from A factorial n, from here factorial n, from here factorial n, how many times? Factorial m times. So factorial n raised to the power m sequences. These are the possible sequences. Among these we have to find out the optimum sequence which will minimize the time, elapsed time. Fine. So this is our problem. Now specifically in this category we are having 4 problems. When n jobs are to be processed on 2 machines AB and the order is AB, that means order of ABC is already assigned AB. N jobs to be processed on 3 machines ABC, order is ABC. N jobs to be processed on m number of machines and the order is ABC. And last is 2 jobs to be processed on m machines. Fine. So these are the 4 types of problems. These are the general assumptions. Machines are available all the time. Jobs are available at time t is equal to 0. No job splitting. No job interruption. Processing times are known and deterministic. Times are already given to you. And no machine may process more than one job at a time. That means at a time only one job is possible on a particular machine. Now here first we are considering 2 machine and n job problem. So consider n jobs is to be proceed on 2 machines A and B in order AB. No passing is allowed. This is our assumption. That is, all jobs must go first on the machine A and then on machine B. So this is the order. Fine. Here notations are capital AI represents the total time required by job I on machine A. BI is the time required by job I on machine B. Capital T is the total elapsed time for the completion of all the n jobs, and capital XI is the ideal time of machine B from the end of I minus 1th job to the start of ith job. Actually, this time is the time when particular machine B, because here we are having only two machines. We are not talking about A, we are talking about B. So this machine B is in rest position. That means there is no working between I minus 1th job to job I. Then this time is denoted by XI. Fine, there is no work on this machine between these jobs. I minus 1th job, end of the I minus 1th job to and the start of ith job. Then this time is denoted by capital XI and known as ideal time. Fine. Now our aim is to find out this optimum sequence, factorial n. These are the possible sequences. Among these, our target is to find out this sequence L1, L2, Ln, optimum sequence. Let us take one example to understand the procedure. Here we have taken 5 jobs which are to be processed on two machines A and B. This is machine A, this is machine B. Let us start with this start point. From here to here, this is time 0. Now processing is start. First job is processed on machine A. This will take A1 time and finished here. Then A2 second job is start, and after A2 time this will be finished. Then third job will be start, and this will take A3 time and finished at this point. Then fourth job will start, and this will take A4 time and finished here. Then fifth job will start after A5 time. At this moment this work will be finished. And now after this onward, machine A is in ideal position, that means in rest position. So after this point till the end of the point, this is the end point, this is the end point, this is the ideal time of machine A. This is the ideal time of machine A. This is the ideal time of machine A. Fine. Now here, because order is AB, that's after finishing of first job on machine A, the product is sent to the on machine B. That's why from here to here, machine B is in ideal position. So that's why this is the first ideal time on machine B and denoted by capital X1. Now machine B start its functioning at this moment. Now first job is processed, and suppose this will take B1 time and ends here. But from here second product or after second job will come at this machine at this moment immediately. So there is a gap. So this gap is nothing but the ideal time. Between this gap, during this gap, machine is in ideal position. So x2 is the ideal time again. Now after this, when product came here, second job start on machine B, and this will take B2 time and finished here. But immediately third product will come here, and now machine start its functioning on machine B. So this is, and it will take B3 time, so finished here. But after doing fourth job, product will come here at this moment. So again there is a gap. So this gap is nothing but the ideal time for machine B. So during this, machine B is in rest position. So x3 is the another ideal time. then fourth will product will come here and then processing its functioning, so take before time, and after this finished its work. Then immediately fifth one come here and then processed on machine B. After B5 time this will end. So this is the total. So at this moment all the jobs are processed on machine A as well as on machine B, and that's why this is the end point. So total elapsed time is actually starting point, this starting point on machine A and end point on machine B, or equivalently this is from this can be understood as the starting point, the start to the end. So this is the total elapsed time. Now mathematically you can see T is nothing but B1 plus B2 plus B3 plus B4 plus B5 plus these ideal times. That means these are the ideal times, these are the processing time. But we know that this is fixed. This is already given to you. This is already given to you. So only unknown is this x1 plus x2 plus x3. Variable quantity. This is fixed. So we cannot deal with this. We will deal only with this part. And our aim is to minimize this. This is our problem. Fine. So now we will discuss the procedure and example in the next video. Thank you.